The goal of this lesson is to make sure that you understand the properties of series and parallel circuits. We're going to start by analyzing a simple circuit, one that contains batteries and a single resistor. I'd like you to predict the values that are going to appear on these 2 meters. So there are 2 batteries in our battery pack, and our resistor has the colors green, orange, black. Pause the video and figure out the value of the current through this resistor. Figure out the voltage on the resistor. Okay, when you did this, since we had 2 batteries and they're each 1.5, we should get a voltage of 3. You should have calculated a current of about 56 milliamps. So 3 volts, 56 milliamps. Simple circuit. Just use Ohm's law to figure out the values. We now want to look at a series circuit. A series circuit is one in which there is only one path for the electrons to follow. Take a moment, pause this video, and draw out this circuit. 3 resistors and 1 battery box. Now enter in the values into your picture. So there are 4 batteries. And write down the values of current going into the first resistor. Now in your drawing, add these values. 4 batteries. Current going into resistor 1 of 53 milliamps. Voltage on resistor 1 of 3.2 volts. Current going into the second resistor, 53.4 milliamps. A voltage of 0.8 volts. Current going into the third resistor, 53.5 milliamps. And a voltage of around 2. Okay, so now you should have a picture that looks like this. You have your resistor values underneath of your resistors based on the colors of the resistors. Blue, black is 60. Brown, yellow is 14. And orange, purple is 37. Since black is the third stripe, we can ignore it. Okay, the battery pack had 4 batteries, so that's a total of 6 volts. We saw the currents and voltages on each of the meters. And now we want to look for trends. So the first thing you notice for a series circuit is that the current is the same in all parts of the circuit. You'll also notice that the voltages are different, but they add up to the total voltage. So if you add the 3 voltages together, you'll get the voltage of your power supply. Finally, you'll notice that the larger resistor uses up more voltage. If you remember that voltage is the energy per charge, it makes sense that the larger resistor is harder to move through, so more energy will be consumed moving through it than any of the other resistors. The total energy consumed has to equal the energy given by the battery. So mathematically, here's the formulas. Currents are all equal, voltages add up to the total voltage, and the resistors add up to the total resistance. So the way we would predict how much current's going to come out of the battery is we would total up our resistors, then we would use Ohm's law to calculate I. So if you use 6 volts and the total resistance, you should get the current of about 53.4 milliamps. Okay, some other things with series circuits is that if we take components out of a series circuit, in this case light bulbs, we'll notice that fewer components will lead to more power to each component, so our light bulbs get brighter. When we cut it down to only a single light bulb, it becomes its brightest possible brightness for this battery. Another property of a series circuit is that when we have our circuit and we break the circuit at one spot, in this case we unscrew a light bulb, the entire circuit shuts down. Okay, now we want to focus on parallel circuits. So pause the video and draw out this parallel circuit. Now fill in the values for the different parts of this circuit. There's 5 batteries in the battery box. The voltage on the top resistor, 7.5. 7.5 for the middle resistor, and 7.5 for the bottom resistor. Then we measure our currents. We get about 87.1 in the top resistor, about 501 moving through the middle resistor, and a current of about 176 going through the bottom resistor. When we look at the total coming out of the battery, it comes up to 764. Okay, we now draw our circuit, which you should already have done, and you label your different values. So the top resistor was gray, green, black, that's 85. Then brown, green, black, which is 15. Yellow, red, black, which is 42. We had 5 batteries. We saw the total current. We saw each of the individual currents, and we saw the voltages. Now you look for trends and patterns. Obviously, voltage is the same in all parts of a parallel circuit. Currents, you can see, add together to get us the total current. You can see that the maximum amount of current goes through the smallest resistor. So the formulas we're going to use, all the voltages are equal. The currents add up to the total. And then it turns out that the resistances add up, but not normally. You add up their inverses to get your total resistance. Finally, you can check things and figure other things out using I equals V over R. Okay, in a parallel circuit, one of the other properties that we haven't mentioned yet is if we break one of the branches, the other 2 branches are unaffected. So removing one of the light bulbs has no effect on the other light bulbs. Okay, you should now try this circuit on your own. So pause this and see if you could figure out the voltages and currents in all parts of this circuit. You should then try this one on your own. So pause the video, draw it, and see if you can find the voltages and currents in all parts of this circuit. If you'd like to check your work on the first problem, here's what your answer should have been. And if you'd like to check your answers on the second circuit, here's what your answers should have been. Okay, so hopefully you have a better understanding of how to work with series and parallel circuits.